The topic of this section is volume thermal expansion. The volume of a normal material increases as the temperature increases. Most solids and liquids behave in this fashion. By analogy with linear thermal expansion, the change in volume delta V is proportional to the change in temperature delta T into the initial volume V0, provided the change in temperature is not too large. These two proportionalities can be expressed as the following equation with the aid of a proportionality constant beta, known as the coefficient of volume expansion. Delta V equals beta V0 delta T. The algebraic form of this equation is similar to that for linear expansion, delta L equals alpha L0 delta T. The unit for beta, like that for alpha, is inverse Celsius degrees. Values for beta depend on the nature of the material, and the table lists some examples measured near 20 degrees Celsius. There are a few things to note on this table. First, for most solids, the coefficient of volume expansion is about 3 times as much as the coefficient of linear expansion, or beta is approximately 3 times alpha. Next, the values of beta for liquids are substantially larger than those for solids, because liquids typically expand more than solids given the same initial volumes and temperature changes. If a cavity exists within a solid object, the volume of the cavity increases when the object expands, just as if the cavity were filled with the surrounding material. The expansion of the cavity is analogous to the expansion of a hole in a sheet of material. Accordingly, the change in volume of a cavity can be found by using the relation delta V equals beta V0 delta T, where beta is the coefficient of volume expansion of the material that surrounds the cavity. As a final note, although most substances expand when heated, a few do not. For instance, if water at 0 degrees Celsius is heated, its volume decreases until the temperature reaches 4 degrees Celsius. Above 4 degrees Celsius, water behaves normally and its volume increases as the temperature increases. Because a given mass of water has a minimum volume at 4 degrees Celsius, the density, or mass per unit volume of water, is greatest at 4 degrees Celsius.